Hello, my name is Sam. Today I'm going to talk about exponential growth and decay. An exponential function has the form of f of x is equal to a times b raised to x. If b is greater than 1, then we say the function has an exponential growth, and when graphed, as you can see, the slope increases, which means the graph gets steeper. Now, if b is greater than 0 but less than 1, then we say that the function has exponential decay, and when graphed, you can see that the slope gets lower, so which means that the line gets flatter. Now let's try example problem. A bank account with $2,500 has an annual interest rate of 6% compounded monthly. How much money will be in the account after 3 years? So we need to find the total amount after 3 years. So first, the initial amount is $2,500. Next, we need to find the rate. Now it says it's 6%, but that's an annual interest rate, which is compounded monthly, which means the 6% is split 12 times. So 6% divided by 12 is equal to 0.005 or 0.5%. So the money will increase by this amount per calculation. So if we do this, we'll just get the value, that amount of increase. We want to know the final total value, so I'll add 1 to this, so plus 1, and then we need to multiply this for 3 years, and it's compounded monthly, which means the total of 12 times 3 times, which is equal to 36. So this will be multiplied 36 times. So if you use a calculator, so 2,500 times 1.005 raised to 36, we get 2,991 $70. So after 3 years, the account will have approximately $2,991.70. Now, most banks calculate the interest continuously, which means that the interest is calculated infinitely during the year. If we write the b, or the interest rate part of the equation, we get 1 plus the rate of increase of percentage in a certain time interval, and we divide that by the number of times that the interest is calculated during that time interval, and we raise that to the number of times it is calculated in a certain time interval times the number of the length of time that it is applied. If the interest is compounded continuously, that means the number of times will be infinite. Now, as the number of times increase, the number will increase a certain number, which we call e, and it is approximately equal to 2.718, and we can try this question again, but assuming that it is compounded continuously. We can calculate it by multiplying 2500 by e raised to the power of the rate, which is 0.06, times the length of time, in this case 3 years. So we use a calculator again. 2500 times e raised to 0.06 times 3, and we get it is equal to approximately $2,993.04. So that's the amount that will be in the bank if the interest is compounded continuously. Nobelium has a half-life of 58 minutes. How much of 100 grams of nobelium will be left after 30 minutes? Now we need to find how much nobelium will be left after 30 minutes. So 100 grams times a rate, but we don't know the rate right now, so we need to find that out. We see that nobelium has a half-life of 58 minutes, which means half of a certain amount of nobelium will decay in 38 minutes. So we can write half will remain of 1 when multiplied by a certain rate for 38 minutes. Now we can rearrange this and get b, or the rate, is equal to the 58th root of 1 over 2. So we can use this to find the answer. So we need to know after 30 minutes. So if we use a calculator, we get 100 times 58 root of 1 over 2, and that is raised by 30, and we get about 70 grams, and that is the answer. Thank you for watching this video. I hope it helped.